In this video, we're going to talk about converting to standard form. So remember that there are three ways to write equations of parabolas or quadratics. And the way we're going to talk about today is standard form. So with standard form, the equation in this example is x squared plus 6x plus 8. It's the way we're probably used to seeing it. And it's really helpful and easy to find the y-intercept. But for other stuff, it's not so helpful. Vertex form is another one, which obviously is very helpful to find the vertex. In this case, the vertex is -3 and -1. And then we've been working recently on factored form, where they give you the factors and you can figure out the roots. So in some of the work we had done before, we had an example where we went from standard form, this form, down to factored form. And of course, the way to convert from standard form to factored form is, of course, to factor. So we would take that, factor it, and get the roots. What we're interested in doing now is going the opposite way. If you have it in factored form, how do I get it in standard form? Well, it's the opposite of factoring, which is expanding. So that's what we're going to do today. Now, you can also go from vertex to standard form by expanding, and we'll see examples of that. So how do we go from vertex or factored form? We have to expand or rainbow, and that's what this video lesson is all about. Okay, so here's two examples. In the first one, it's y equals 2 bracket x minus 1 times x plus 3. So you'll notice that we are multiplying three things together. We've got the 2 times the x minus 1 and times the x plus 3. When you're multiplying three things together, you can pick any two of those, multiply them together, and then take that answer and multiply it by the third. So there's a couple of ways that we could do this. We could multiply the first two together, but what I'm going to do, and probably do most often, is I'm going to multiply the factor parts. So I'm just going to multiply the last two, and that's a plain old rainbow. So x times x is x squared. Then we go x times 3, which is 3x. Then -1 times x is -1x. And -1 times 3 is -3. And now, of course, I can simplify inside the brackets like its own little question. I've got common like terms, 3x and minus x, so that's x squared plus 2x minus 3. And now that's multiplying the last two things together. Now I have to take that answer and multiply it by 2, the third thing that I see here. So I'm going to have to rainbow that 2 in to the other one. So it's going to be 2 times x squared, which is 2x squared, 2 times 2x, which is 4x, and 2 times -3 is -6. And there I have the equation of that same graph, but in standard form. Now, that was multiplying the last two things together, but another way you could do is multiply the first two things. So those two things, the 2 and the x minus 1. That'd be like a little mini rainbow. So let's do that down here and see if we get the same answer. So 2 times x is 2x, and 2 times -1 is -2. Then I have to take that and multiply it by the third thing, which is x plus 3. So now I'm going to rainbow this binomial times a binomial. So 2x times x in 2x squared. Then I'm going to take the 2x and multiply it by 3 and get 6x. -2x, or it's -2 times x is -2x. And -2 times 3 is -6. Collect my like terms. And I get 2x squared plus 4x, because 6 minus 2 is 4, minus 6. And you see that that's the same answer as I got when I multiplied the second two things together. So it doesn't matter which multiplication you find easier. I will probably do, you could even multiply the 2 times the x plus 3 if you wanted, and then multiply that answer by x minus 1. But I think I'm going to do this one where I multiply the factored parts and then rainbow in the a value later. So let's try this second example. Now you'll notice that this one is actually in vertex form. And we can also go from vertex form to standard form. So we're going to do that by saying, notice that this is x plus 3 squared. And the squared means it gets multiplied by itself, so it's another x plus 3. So by writing it out this way, you can see that it looks kind of like the questions we've been doing. And we'll just rainbow out the x plus 3 times the x plus 3. So let's do that right now. Remember this minus, it looks like it's in factored form. It's not in factored form though, because that minus 1, which is just at the end. So, oops, sorry about that. So it's not quite factored form, but you're going to still rainbow this one. So I like to rainbow the middle parts first, the x plus 3 times the x plus 3. So I'll leave the negative 4 alone. X times x is x squared, plus x times 3 is 3x. And then I've got a 3 times x and a 3 times 3. So that'll be 3x, and then 3 times 3 is 9. And then don't forget that minus 1 hanging at the end. Inside the brackets, I have a 3x and a 3x. So I can collect like terms in there and get x squared plus 6x plus 9 minus 1. Now I'm going to rainbow the negative 4 into that trinomial. So I have negative 4. Remember, don't rainbow it with a negative 1 at the end. That's not inside the brackets. So if I rainbow the negative 4, I get negative 4x squared minus 24x, because that's a negative times a positive, and then minus 36. And then the minus 1 is just hanging along in the end. Now I can start considering that negative 1 and negative 36. So I get negative 4x squared minus 24x minus 37. And that is the standard form for this vertex form that I have up at the top. All right, so we've seen 2 examples now. So I'm going to ask the teacher to, before I move on though, please don't make this grade 9 mistake. I've seen lots of people when they do x plus 3 squared, they just square the x and square the 3 and say it's x squared plus 9. That's not true. Remember, squared means it gets multiplied by x plus 3. It gets multiplied by itself. So you end up with that third term. So make sure you don't make this grade 9 mistake. You're going to have that middle term there. Okay, so it's not, you don't just square each of them. You got to rainbow it out. That's why I write it down twice, so that I don't make that mistake. Okay, so here I'm going to ask the teacher to pause the video and give you time to go off and try these questions on your own. And then you can come back in a bit to watch the answers. Okay, so I'm going to do these really quickly. So I'm just going to rainbow these. You've had a chance to try them. So I'm rainbowing them inside here. X times x is x squared. X times 5 is 5x. Negative 1 times 1 is negative 1x. And minus 5 at the end. Collect like terms and I get 4x in there. Then I'm going to rainbow the 3. So 3 times x squared is 3x squared plus 12x minus 15. Again, I know I did that quickly, but you've had a chance to try this, and this is just me showing you the answers. In the second one, you see that I have x plus 4 squared. So to avoid that grade 9 mistake, I'm going to write it down twice. Now I'm going to rainbow the x minus 4 times the x minus 4, which is x squared minus 4x minus another 4x plus 16 and the minus 1 at the end. Collect like terms inside, and I get a minus 8x inside. Now I can rainbow not just the 2, but a negative 2. And so rainbowing that gets me negative 2x squared plus 16, because it's a negative times a negative, minus 32 with a minus 1 hanging at the end, and then just get a minus 33 in that last collection. In C, you'll see that we have another one that's being squared. So again, to avoid the grade 9 mistake, I'm going to write this out twice. So this equals 3 bracket x minus 1 times x minus 1, with the 9 is 27 hanging around there. Rainbow the middle, and I get 3 times x squared minus x minus another x plus 1 minus the 27. Collect like terms inside, x squared minus 2x plus 1 minus 27. Rainbow the 3x squared minus 6x plus 3 with a minus 27. And then I can collect the 3 and the minus 27 at the end to get 3x squared minus 6x minus 24. Hopefully that is what you got as well. Now in D, you'll see there's just a negative. Well, remember that there's actually a number in front of there. That negative actually represents a negative 1. So we can put a 1 right in there to remind us that. But I'm not going to rainbow the negative until I'm going to rainbow the x plus 2 and the x minus 4. So let's rainbow that right now. X squared minus 4x plus 2x minus 8. Collect like terms in the middle, and I get a negative 2x in the middle. Now I can deal with that negative and rainbow the negative 1 through. So multiplying everything by negative 1 is going to change the sign. So it'll be negative x squared plus 2x, because a negative times a negative is positive, and a plus 8. Okay, so hopefully that matches what you did on the whiteboard or did on your own, and you have a good understanding of converting into standard form by expanding. Now, what I'm going to do here now is I'm just going to check my answers on Desmos. So if you go off here and go to desmos.com/calculator, and we can check to see if we still have the same equation. So let me just do split screen here so I can see what the one. I'll do that last one there that I had right here. So that was negative bracket x plus 2 times, so bracket, another bracket, x minus 4. So you see there's the parabola up there. That's what the question was. Now I want to check and see if my answer gets me the same parabola. So my answer was y equals negative x squared plus 2x plus 8. And you should see that it just went over top of the old one. That means my blue graph is the same as my red graph, which means I have the exact same equation, and this must be correct. Let's try it with another one. Let's do that top one, the first one there. It's a little messy, but I think we can see it. So we've got 2 bracket x minus 1 times x plus 3. So this gets us a new parabola. And we did the work, and we got the answer is 2x squared plus 4x minus 6. And you see that the blue one went over top of the red one. So again, you can see that this must be the correct answer because it produces the exact same parabola. So you can use Desmos to check all of your work. We've been doing that quite a bit, and that wouldn't be a bad idea whatsoever. All right, well, I guess that's everything, and thanks for watching.